Peyton. Hurry up, Peyton. It's 9:45. Everybody follow along with me on number 9. I'm not sure we've talked about perimeter. Did you guys have a perimeter problem on Friday's assignment? Do you guys remember what the perimeter is? Akira, what's perimeter? Right. So it's the length of the distance all the way around a square-sided figure or a straight-sided figure, right? So the perimeter of this rectangle, let's not do that. Let's just do the perimeter of this rectangle. This side is 20, that means this side is 20. If this side is 10, that means this side is 10. The perimeter is the sum of all the sides. So it's 20 plus 20 plus 10 plus 10. 20 and 20 is 40, 50, 60. So we add all the sides. Does that make sense? This would be, we could take a shortcut, 2 times the 20 plus 2 times the 10s, right? And so that perimeter would be 60. This problem, we have a triangle. Well, so let's talk about a perimeter triangle before we do the one with the weird side length. So if we had a triangle with 2, 3, 4, that's the side length. We can add, to get the perimeter of a triangle, we just add all the sides. So that perimeter would be 9. Anybody follow along with me? Naya is. Brandon, you follow along with me? Tunisia is? Odds. Well, you're doing all of them for homework, but I'm doing the odds with you today. But you're doing all of them on both review worksheets. You should be completing all of them. All right, so this problem, though, asks you to do something a little bit different. This problem gives you the perimeter and gives you 2 side lengths. So one side, another side, and they want you to find the third side. All right? So how we would do that, let's say we had a regular triangle. So let's say it was 3 and 4, but we don't know what that side length is. If we know the perimeter is 12, how could we find the side length? Well, we know that the perimeter is going to be 3 plus 4 plus something. Well, now we know the perimeter is 12, right? So we know the perimeter is 12. It's going to be 7 plus some number. So we can just subtract this 7 from 12, and now we know that that third side would be 5. 12 minus 7 is 5. That make sense, Anson? So for this one, even though it doesn't have normal side measures, I don't want to put it there. I don't want y'all to put it there. Let's do this one over here. So one side measure is 2b. One side measure is 3b plus 8. We want to know the other side measure, and we know the perimeter is 15b plus 3. So what would we do to find that side measure? You follow with me, Brandon? So up there, when we had actual numbers for the side measure, we added the 2 sides together and we subtracted from the perimeter. That's the same thing we're going to do here. But a little different, right? So side 1 plus side 2, 2b plus 3b plus 8. What does that equal? You got to add the 2b and 3b. Right, so that's 5b plus 8, that's right. So now we know that these 2 sides, if you add them together, are 5b plus 8. To find the third side, we have to subtract it from the perimeter. So that's going to be 15b plus 3 minus 5b plus 8. And this is one you have to remember to distribute that minus to everything. So that's going to be 15b minus 5, oh, let's put plus 3 back in there. Plus 3 minus 5b and minus 8. That makes sense? And so now the things that we can add together are like terms will be 15b minus 5b, that's going to be 10b. 3 minus 8, those are like terms, that's going to be negative 5. So that is the length of the third side. Does that make sense? Does that make sense, Peyton? All right. Anybody have questions on number 9? All right, we're going to move on to number 11. Number 11, Stephen right here. Sorry? Where are you? Is this it right here? Yes. So how many terms are there? Well, 1, once you simplify that, so what do we call a one-term polynomial? Yep. So it would be a fifth degree monomial. Yep. Yes. Have you done anything that we're doing yet? All right, let's go. 951. Number 11. 4b to the fourth times 2c to the fifth plus 7 times t minus 3. 4p to the fourth minus 2c to the fifth. Number times number, variable times variable. You follow with that, Jeremiah? So number times number, what would we get when we multiply 4b to the fourth times 2b to the fifth? You follow with that slide? What would you get? 4b to the fourth times 2b to the fifth. Do you know? Number times number, 4 times 2, variable times variable. So t to the fourth times t to the fifth. What is t to the fourth times t to the fifth? Like basis, so what do we do with the exponent? T to the fourth times, what's t times t? What's t squared times t? T3, right? Because t's got an exponent of 1, right? What's t, so this is t to the fourth times t to the fifth. We just add the exponent. So it's going to be a t. 4 plus 5 is 9, remember? Okay. So now we're going to do 4p to the fourth times 7p. Number times number, so it's a positive 28. What's t to the fourth times p? Answer, what's t to the fourth times p? T to the fifth, very good. And now we have 4p to the fourth times negative 3. That's minus 3, right? Number times number, that's minus 12. And I've got a variable, I can't leave it. I have to include that in my answer. So that is the final answer for 11. 8p to the ninth plus 28p to the fifth minus 12p to the fourth. Any questions on 11? All right, 13. 13, negative 6n times 3n squared plus 5n minus 4. So we distribute. Number times number. Negative 18. What is the exponent on the n going to be? What's the exponent on the n going to be? You follow along with that, Tracy? No? Brooklyn, what's the exponent on n going to be? What's n times n squared? Well, what's the exponent on the n if you don't see one? 1. This is n to the first times n to the second. So I'll tell you it's not n to the second. What do you think it might be? Yes, very good. Into the third power, because we add the exponents, right? So negative 6n times positive 5n, number times number, use your calculator. 6 negative button times 5 gives you negative 30. What is n times n, Peyton? What's n times n? What's n times n? Naya, do you know what n times n is? Have to know n times n, guys. N to the first times n to the first, Diane? N to the second, thank you. Negative 6n times negative 4, use your calculator. 6 negative button times 4 negative button, you'll see that is a positive 24. N, there's nothing to multiply with, so we just include our n in our answer. 16, factor each polynomial. So remember, greatest common factor first, and then we're going to use some parentheses. There's 1, 2, 3 terms. Going to fill in the blank. So what is the greatest common factor of 6k cubed plus 12k squared minus 24? What's the greatest common factor? Kendall, are you awake? You follow along with us? Yes or no? Okay. Jeremiah, what do these, all three of these terms have in common? Do they have a numerical factor in common? And so they have a factor that's the same, it's a number? Okay, what do you think it might be? 6, 12, and 24. What do you think it might be? So remember how to do it if you're stumped. Do the factors of each of the numbers. 1 and 6 are factors of 6, and 2 and 3 are factors of 6, right? So if you do the factors of 12, 1 and 12, 2 and 6, 3 and 4. So if you do the factors of 24, it doesn't matter if it's negative. 1 and 24, 2 and 12, 3 and 8, 4 and 6. So look at all sets of factors. What's the biggest number they all have in common, Jeremiah? Oh, thanks. What's the biggest number they all have in common? Does 6 have a 12? No, the 12 here, right. But what about the 6? 6, 6, 6. That's the biggest one they have in common, right? So that's our greatest common factor. And I'm just going to go ahead and write that there. So now I've got to fill in something before. Danielle, are you feeling bad? Do you need to go to clinic? Well, you got to keep your head up then. If you're feeling good enough now to go to the clinic, you got to be working. Alright, so now we look at our greatest common factor, and we're going to figure out if we multiply this greatest common factor by something, it has to equal this first term. Right, so 6 times what would give me 6k squared? Brandon, 6 times what would give me 6k squared? I'm sorry, 6k cubed. 6 times what would give me 6k cubed? You're not following on with us? Oh, okay. So Darren, you follow along with us? So 6 times what would give us 6k cubed, buddy? Just a k cubed, right? We don't have, so we did not, I should have clarified maybe, but we can't put a k on all of these and no variables because there's not a variable in this term. So 6 times k cubed, that's 6k cubed. That's what we're looking to do. 6 times something that will give me 12k squared. What would that something be? Well, 6 times what gives me 12, Peyton? Yes. And then it's just a k squared because I don't have any variables to multiply by. 6 times what gives me 24? Well, I can look up here, my list of factors, 6 times 4. So that's it. That's all you need is factor them. rectangle has a length of 5x plus 2 and a width of 3x plus 3, what is the area of the rectangle? So I want you to draw a picture. The length is 5x plus 2, and the width is 3x plus 6. So length and width, we have to remember the area formula for a rectangle is length times width. So we just plug in for the L, plug in for the W. That means we are multiplying 5x plus 2 times 3x plus 6. And then we're going to use the distributive property. Remember, this is where we draw arrows. We need arrow from here to here, and arrow from here to here. So 5x times 3x. What is 5x times 3x? Xavier, you follow along with me? 5x times 3x, Severian. 5x times 3x. 15, right, the x has to be what? Squared, right? X times x is x squared. 5x times 6, that's 30x. So now we're going to do the same, but with the other number in that binomial. So 2 times 3x, that's going to be 6x. And 2 times 6, which is 12. This cannot be my final answer because I have like terms. Remember, same variable with the same exponents. I've got to combine those. So my final answer is going to be this x squared term. Don't have anything I can combine it with. What is 30x plus 6x? What's 30x plus 6x, can I ask? What's 30x plus 6x? Not x squared, so if you're adding, remember that exponent never changes. You can only change the exponent on variables if you're multiplying or dividing them. Anytime you're adding variable terms, the exponents never can change. The coefficients get combined. So 30x plus 6x is 36x. And then we've got a constant we have to include in our answer. Any questions? So the last ones are ones that we can do with the shortcut. If the shortcut is confusing to you, you can do them the long way. I'm going to do them with the shortcut because that's why we covered that section. So 19, t plus 7 squared. Remember, that's the same as this. I'm not going to use that way. You could distribute. We learned a shortcut. The shortcut is square the first term. You square p, you get p squared. To find the middle term, you multiply these, so 7 times t, and then you double it. So 7 times t, which is 7t, times 2, which is 14t. And the last part of that shortcut is to square the 7, the last term. That would be 7 squared. If you do it in your calculator, you'll see it's 49. There will be problems like these next two that you have to fill in the box. Alright, so we're looking to see in number 21. The product is s squared minus s minus 20. They give us one of the factors is s plus 4. Makes sense. S times s is s squared. But what do we have to multiply this by in order to get a product of negative 20 here? Well, if we can't put a positive number there because this number has to be negative. Well, we know that 4 times 5 is 20, right? And that's what we're looking at, the constant times the constant. So this number times this number has to equal that number. So what times 4 would give us a negative 20? Well, if you're not sure, use your calculator. 20 negative button, and then divide it by the positive 4, and you'll see that that's actually a negative 5. So for 21, that box should be filled with negative 5. Any questions? Either you don't appear to be following with me or doing it on your own. Aren't you supposed to be one or the other, right, Lenny? You'll be writing what I'm writing in the video if that's what you're watching. binomials. These are almost identical, but one is addition and one is subtraction. That is what we're looking for our other shortcut. We have identical binomials except one has an addition symbol and one has a subtraction. We can use our other shortcut. That shortcut would be for the special product, the difference of squares. So for the difference of squares, we simply square that first term or multiply those first terms. That was the same thing as squaring. So that would be j squared. It's always minus, and we square the second term, and that would be 49. So that shortcut looks like it's division, but it's not a subtraction. It's always first term squared minus the second term squared. Explain how you add or subtract polynomials. What would you think? Anybody? How do you add and subtract polynomials? We add the coefficients or subtract the coefficients of the like terms. Right? So to add and subtract polynomials, add and subtract the coefficients combine like terms and you write in standard form. Something like that would be fine. So we've done 9 through 25, the odds. We'll go back and do the first section of the odds on the first page. Did you check it for mastery? The answer to use on today's date and table. Find the degree of each polynomial. So remember, if it's just one term, that means there's no addition or subtraction. You find the degree by adding the exponents on only the variables. We don't count that -4. It has a degree of 0. This a is an exponent of 1. So to find the degree of this one-term polynomial, we add 1 plus 2. Those are the degrees. So the degree of this polynomial is 3. Now this is a two-term polynomial, since we can't combine anything, so now we find the degree of each term. And if you don't see that exponent, it's a 1. So the degree of this term, from the front side here, Maya. Here's where we are right here. So this is n to the 4th times n plus 11, a to the 4th times b to the 5th. So that's 4 plus 1 there. So the degree of that term is 5. The degree of this term, 4 plus 5 is 9. We do not add these together. We added 4 plus 1 to get 5. We added 4 plus 5 to get 9. Now for the two-term or three-term or multi-term polynomial, we pick the biggest one. So the degree of that term is, or that polynomial is 9. Any questions on that? Okay. For the rest of these, you have to combine it. You have to add or subtract, combine like terms, and then tell the degree, and then name it by the number of terms. So 4n plus 12 plus 6, 4n squared plus 12 plus 6n squared plus 3. We can just mark our like terms and combine them. What is 4n squared plus 6n squared, Anson? Then what? 10x squared, right? 10 n squared. And then 12 plus 3 is 15, positive 15. So now this is our simplified answers in standard form of the greatest degree to least degree, degree of 2, degree of 0. How many terms are in that? How many terms are in that, Peyton? Terms are separated by addition and subtraction. So when there's one addition symbol, it separates two terms. So we call this two terms. What's the special name for a two-term polynomial? Say again? A binomial. Right? So we know it's a binomial, and we're going to get the degree above that. So what is the degree? Well, we look at the degree of each of the terms. The degree of this term is 2. The degree of this term is 0. So the biggest one is 2. So it's a second degree binomial. Number 7. We've got two terms, so once we simplify it, these are like terms. T to the 5th, T to the 6th. So we combine them by adding their numerical parts, adding their coefficients. 8t to the 5th. And a one-term polynomial, you guys remember what a one-term polynomial is called? Monomial. Mono means 1. And the degree of this is 5. So that is a 5th degree monomial. We know the degree of this is only one term, and there's only one variable, and it has an exponent of 5, so that has to be the degree. I'll fix it. All right, I think that means we've done all of the odd problems. I am going to post this to the website, the homepage, for our course. If you need to go back and look at them, then you can when you're doing the even problems. And test tomorrow, don't forget. And that means all makeup work is due tomorrow, right?